All right, welcome everybody. Today we're going to talk about lesson number 64, and this is all about solving trig equations and finding exact values. Now, if those two things sound familiar, we have already done both of those. We're just going to extend upon them today using some of the different formulas that we've been using in the second half of the chapter. So take a look here at the directions. Solve each equation using the general solution. Focus on the formulas as well as your algebraic techniques. So if you think back to the mini quiz from last week, which again, most of you did very well on, you're doing those same things right now, but you're having a renewed focus on using the new formulas. These are all going to be the general solution. Remember, I can still go back and forth between 0 to 2 pi and the general, and you also might have to use the calculator in some cases, so be prepared for all contingencies. Here in number 1, you have the sine of 2x, cos of 2x, minus cos of 2x, and sine x equals 0. Now, be careful. Technically, the sine of 2x and the cos of 2x, those are both formulas. But before you jump right in and replace both of those, try to look at the big picture. If you take a look at the entire thing, that's actually a formula in and of itself, and it's going to be much easier if I deal with the whole thing at once. So sine cos minus cosine. While you should always go back to your formula sheet to double check, you should at this point be able to at least recognize where you should be looking on the sheet. So if you're looking for a sine cos minus a cosine, that's right here, the sine of u minus v. So the sine of u minus v, in this case, u is 2x and v is just x. So this is going to become the sine of 2x minus x equals 0. 2x minus x is just 1x equals 0. And that's a very nice simple equation. So if drawing the picture helps you, remember that sines are y values. Y values that have a value of 0 happen at 0 and pi. You're basically looking to say all the multiples of pi, so 0, pi, 2 pi, 3 pi, and the easiest way for you to say that is pi n. Remember, you could technically say 0 plus pi n or pi plus pi n. There are a bunch of different equivalent solutions. My advice is try to find the easiest one. And again, of course, when it comes to the general solution, you have to remember to have the n's of some kind. Again, if you had started off by replacing the sine of 2x and the cosine of 2x, you still would have been able to get to the right answer, but it would have taken you a heck of a long time. So, try to look at the big picture when you can. Now take a look at number 2, 2 times the cosine of x plus the sine of 2x. Again, just make sure you're aware that, first of all, this is problem number 2, so has nothing to do with it. This is a 2 on the outside, which means you technically could move that around. This 2 on the inside is sacred. You're not allowed to use that 2 unless it's the final step or unless it's a formula. So the sine of 2x altogether, that is a formula. So I'm going to go ahead and make that replacement. So 2 cosine of x plus 2 sine x cos x equal to 0. And again, this is the formula. From here, hopefully you would recognize that you have two different terms, and you're going to go ahead and factor out the greatest common factor. So the greatest common factor is a 2 cosine. That would leave you with a 1 plus sine equals 0. If you set 2 cos x equals 0, you're going to get that cos of x is equal to 0. Or 1 plus sine of x equals 0, you're going to get that sine of x is equal to negative 1. So if you think about your cosine of x equaling 0, that happens at the top and at the bottom. If you think about the sine of x equaling negative 1, that happens only at the bottom as well. So it turns out that because this is pi over 2 and 3 pi over 2 and 3 pi over 2 again, you can actually combine all those answers to just write one simple expression. So you're looking to start at pi over 2 and then go to 3 pi over 2 and then go back, which means you only need pi n between them. And again, this doesn't happen all that often, but in this case, because you had repeat answers, meaning pi over 2, 3 pi over 2, and then 3 pi over 2 again, that one singular purple equation is all you need to encompass all of the solutions. So again, if you were doing well at the solving equations, this is really not all that different, except you're focusing on the formulas. So take a look at number 3, the sine of x plus pi minus sine of x minus 1 equals 0. Hopefully, jumping out at you here is the sine of x plus pi. And of course, you're going to think of this as the sine of u plus v. Let me make that a little more V-like. I know, U's and V's, terrible letters. I don't know who decided to pick two that are so similarly shaped, but I don't make the rules, I just follow them. So from here, I'm going to go ahead and do the sine of u plus v. So that is the sine of the first thing, x, times the cosine of the second thing, which is pi, then plus the cosine of the first thing, which is x, times the sine of the second thing, which is pi, and then minus sine x minus 1 is equal to 0. And again, maybe the colors help just to help you understand where exactly the formulas are located in relation to each other. Don't forget that other stuff, though, minus sine minus 1. Again, hopefully looking at these problems, you notice now that you have some unit circle values. So those unit circle values, you can and should replace them. So sine of x, the cosine of pi, either you've memorized it or your unit circle is going to tell you that it's negative 1. The sine of pi, that's a 0. Minus sine minus 1 equals 0. Taking a look here, the cosine of x times 0, that's simply going to cancel out. This is going to give you negative sine of x minus sine of x minus 1 equals 0. Well, certainly a negative sign minus a sign, that's a negative 2 sign. And I'm going to add the 1 to the right-hand side. So I'm going to get down to the fact that sine of x equals negative 1/2. Signs are, of course, y values, and y values are negative in the third and fourth quadrant. So I'm looking for answers here and here. Then you have to make sure that you have the correct family. So this is the pi over 6 family. So this is 7 pi over 6 and 11 pi over 6. Because of the fact that those values are not equidistant, you're going to have to start at 7 pi over 6 and go all the way around 2 pi n. And then you're going to have to start at 11 pi over 6 and go all the way around 2 pi n. So these should be getting faster. They should be getting easier the more you do of them. And again, because you have your formula sheet and your unit circle in front of you, I really don't see how you can go too wrong as long as you are utilizing them. Here in number 4, you have the cosine of 2x minus the cosine of x. Now again, be careful. This cosine of 2x and this cosine of x, you can't subtract them, you can't combine them, you can't divide by 2, you can't do any of that stuff because they are different. So be careful. What you want to do instead is realize that this cosine of 2x is a formula. Actually, the cosine of 2x is 3 different formulas. So you're going to want to choose the one that makes the most sense in the context of the problem. While you could technically use any of them, there is one best, easiest choice glaring you at the face, and hopefully you realize that it's this one. Because of the fact that your problem already has a cosine in it, why not choose the one that only has cosines, and then you should be good to go. So I'm going to go ahead and replace the cosine of 2x with 2 cosine squared x minus 1 minus cos equals 0. And again, a little bit of color coding for you just to make sure you understand exactly where the formula went. Then I'm going to do a little bit of rearranging. So 2 cosine squared minus cos minus 1 is equal to 0. From here, it may or may not be factorable. If it is, great. If it's not, do the quadratic formula. Turns out that it is factorable. You can factor this as the 2 cosine of x plus 1, and then the regular cosine of x minus 1. Based on what I saw on the last quiz, you are pretty much all able to get from here to here. In terms of how you do it, I actually don't really care as long as you can do it. And then from here, you're going to go ahead and get that the cosine of x equals negative 1/2 and the cosine of x equals 1. So the cosine of x equals 1, that happens only over here at 0. So the best way to say that is to say 2 pi n. The cosine equaling negative 1/2, well, cosines are x's, so that is true in quadrants 2 and 3. Make sure you have the right family. It's the pi over 3 family, and 2 and 4 pi over 3, respectively. Again, because of the fact that those values are not equidistant, you're going to have to say 2 pi over 3 plus 2 pi n, and then you're also going to have to say 4 pi over 3 plus 2 pi n. And I would say really the only reason why the only reason why people seem to get any of these questions wrong on the most recent quiz was simply because they didn't read the directions, not necessarily because they didn't know how to do it. So again, just make sure that you're being careful. So get those highlighted for you. So 2 pi n, 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n. Couple of special cases here at the bottom, just to make sure that we are good to go. Take a look here at number 5. So the sine of x, the cos of x equals -1/2. Again, I think a good tip here as we approach these problems is to sometimes remind you what you can't do. What you can't do is say, oh, set the sine of x equal to -1/2 and set the cosine of x equal to -1/2. That is not a thing. That only works if you have 0 and 0 only. So the fact that it's not a 0, please don't try to use the zero product property. Unfortunately, that doesn't work. What you should also notice is that if you look at the left-hand side, you have a single sine and a single cosine, no squares in sight. So no formulas are kind of jumping out at me. Nothing looks exactly the way that it's supposed to. So I have to be a little bit clever. You might not think to do this until I nudge you in the right direction, but hopefully now that I've showed you, you'll think to do it again. The money step here is I'm going to go ahead and multiply both sides by 2. Well, why would I want to do that? Because if I multiply the left side by 2, I'm going to get 2 sine x cos x equals -1. Well, would you look at that? 2 sine x cos x, that's a formula. Now, in pretty much all the problems so far, we have gone from the easier side to the expanded side. This is actually an instance where we're going to want to do the opposite. So I'm going to take that 2 sine cos, and I'm going to write that as the sine of 2x equals -1. Now you have to remember back to a couple of days ago. This was what we called solving with multiple angles. So if you're solving with multiple angles, you want to realize that this is a 2x, so I want to keep that in mind. Then you want to solve the problem as if there wasn't a 2x. So what if the sine was equal to -1? Well, the sine is equal to -1 only down here at the bottom at 3 pi over 2. So if you were solving just sine of x equals -1, you would say that the answer was equal to 3 pi over 2 plus 2 pi n. Hopefully you remember that because of the fact that there's something other than a 1 here, you're going to go ahead and set 2x equal to this problem. Then to get your final answer, you're going to divide by whatever is in front of the x, which in this case means you're going to divide everything by 2. If you divide 3 pi over 2 by 2, that becomes 3 pi over 4, double the denominator. And if you divide 2 pi n by 2, you get pi n, and that's going to be your answer. Now, again, it is less likely that you are going to do a problem like this where you are going to take the expanded version and you're going to rewrite it as the shorter version. So more often than not, the problems are going to look like number 2, 3, and 4. But I do want you to realize that this is an option. So be sure to utilize it when possible. All right, so we've got one last equation here, and notice we have a little bit of tangent action. Just FYI, the problems that have the tangent formulas tend to just be a little bit longer and a little bit more complicated, but still very doable. Starting with trying to identify a formula, you have the tangent of 2x, and then if you go ahead and take a look at your formula sheet, notice that you actually have 2 different options for the tangent of 2u. You're going to use the first one because of the fact that everything in that formula has a tangent in it. Because the original problem is all tangents, better not to bring sines and cosines into it because that just makes it much harder. So we're going to go ahead and go back here, and we're going to replace that tangent of 2x with the formula, which is 2 tan x over 1 minus tangent squared minus 3 tan equals 0. And again, just to kind of reiterate here, so when you go back, you can always tell where the formulas came from. Then you actually have a couple of different options. For me, when I look at this, I see that there are only 2 terms, and I see that it's equal to 0. So to me, I'm going to go ahead and put them on opposite sides. So 2 tan over 1 minus tan squared is equal to 3 tan. Then again, I notice that I have a fraction on the left and a non-fraction on the right. So the easiest way to get rid of those fractions is to cross multiply. So I'm going to go ahead and cross multiply. When I do that, I'm going to get that the 2 tan of x is equal to 3 tan x minus, careful, 3 tan cubed x. Then hopefully from here, you realize that again, it's a tangent party, but now I don't have any fractions and I don't have any multiple angles. So I'm gonna put everything on the same side, the left side preferably. So I'm going to add the 3 tangent cubed, which makes it positive. I'm going to subtract this 3 tan from 2 tan, and that's going to give me a negative 1 tan. Then hopefully from here, it makes sense that I'm going to want to go ahead and factor the GCF out of both pairs. All I can factor out is a tan x. That's going to leave me with a 3 tan squared x minus 1 equals 0. And again, now that I'm down to something times something equals 0, I can go ahead and set each of those values equal to 0. So either the tan of x equals 0, or 3 tan squared x minus 1 equals 0. If I add the 1 and divide by 3, I'm going to get tan squared equals a third. To get rid of the square, take the square root. Don't forget to plus or minus, and hopefully after doing this many times, the square root of 1/3 would simplify to be radical 3 over 3. So again, the more you do of those, you kind of be a little bit of a step skipper, but be careful. So this is a general solution. So the tangent equals 0. So remember, that's a sine over a cosine. That only happens at 0 and at pi. So if you're trying to write that as the general solution, the easiest way is pi n. Remember, there are other equivalent answers, but that's the easiest one. Then, because of the fact that you have the tangent equaling plus or minus, it's all 4 quadrants. Make sure you have the right family, and in this case, it's the pi over 6 family. So again, because it's all 4 quadrants, you can write one equation that gives you pi over 6 plus pi n. That'll take care of quadrants 1 and 3. Then you can do 5 pi over 6 plus pi n, and that will take care of quadrants 2 and 4. And again, just to reiterate why you can't just write pi over 6 plus something n, because of the fact that those members of the pi over 6 family are not equidistant. You can't write it any simpler. Remember, that only works for the pi over 4 family if you're talking about all 4 quadrants. So hopefully, again, just like the proofs, seeing these a second time, even if there are more complicated formulas, makes it a little bit easier. And then we're going to go ahead and finish up by, again, finding something called an exact value. So you'll recall that yesterday we found exact values using the sum and difference formulas. Now we're going to find exact values using the half angle formulas. So a similar procedure, a similar set of steps, and you're going to get some slightly different answers. Just like yesterday, though, there's a finite number of combinations and a finite number of things you can actually find the exact value for. So you're going to get similar answers each time, which is why we're not going to do too many of these. Something important to notice here, though, is when you're using the half angles in particular, those are the ones where you have to choose plus or minus. So I'm going to show you how to do that. So here, you are going to go ahead, find the exact value, which again means no decimals, of the cosine of 5 pi over 8. And in order to find the cosine of 5 pi over 8, you have to be able to divide something from the unit circle by 2. So in this case, the something from the unit circle is 5 pi over 4. If you were to divide that by 2, you would double the denominator. So I want to make clear that 5 pi over 4, that's the u. And then 5 pi over 8, that's the u over 2. So it's important that you understand the difference between who is who. Then if we take a look at our formula sheet, if we're talking about using the cosine formula of the half angle, then we are talking about using this version right here. And then take a look at the note here. It says the signs plus or minus depends on the quadrant of u over 2. So whether u over 2 is positive or negative based on the quadrant, that's how you'll be able to decide if you should choose the positive version or the negative version. So first, let me highlight the formula. Then let me go ahead and write it. So plus or minus, put it to the side here for a second. So plus or minus the square root of 1 plus the cosine of u over 2. So that is the formula that I'm using. So again, because of the fact that u over 2 is 5 pi over 8, you have to determine what quadrant 5 pi over 8 is. And you have a couple of ways that you can do that. You can convert it to degrees. You can plug it in and find the decimal approximation and then use the radian values. You can also keep in mind that if you're talking about the pi over 8, this would be 8 pi over 8 compared to 0 if you use a common denominator, which means this would be 4 pi over 8, which means that 5 pi over 8 has to be here in quadrant 2. Again, lots of different ways that you could figure out that you're in quadrant 2. As long as you can figure it out, that's fine. Then because you're in quadrant 2 and because you're talking about cosines, cosines in quadrant 2 are negative, which is why you're going to choose the negative version of this formula. So put a nice big fat negative on the outside. Then specifically in the formula, you are using 1 plus the cosine of u over 2. So this is going to become 1 plus the cosine of 5 pi over 4 all over 2. The cosine of 5 pi over 4, if you look at your unit circle, that is equal to negative radical 2 over 2. So this becomes 1 minus root 2 over 2 all over 2. And again, whenever you're doing these, complex fractions, that's why you wind up having kind of those annoying extra steps. But unfortunately, it's just something we have to deal with. So from here, I'm going to go ahead and common denominate the numerator. So this becomes the square root of 2 minus radical 2 over 2, and then still over another 2. So again, this is the 2 that made the common denominator up top, and then this is the 2 from the denominator. If I was to do the keep change flip, this is 2 over 1. So I'm going to wind up multiplying by 1 over 2, which means I'm going to get the negative square root of 2 minus radical 2 over 4. And in terms of what answer I'm actually looking for, make sure you have the negative, then the square root, 2 minus radical 2, and then all over regular 2, because of the fact that you can take this square root of 4 from the bottom and actually take the square root of it, which is why it turns out to be a nice regular 2. And then in your numerator, you have the negative square root of 2 minus radical 2. And just so you know, yes, you are allowed to have an answer that looks like that. You are allowed to have a radical within a radical. It happens often, so don't be surprised. And then again, on the bottom is the regular 2. Just to go back for a second and clarify again why you chose the negative, because of the fact that you're trying to find a cosine, you have to realize that 5 pi over 8 is in quadrant 2. Cosines in quadrant 2, x values are negative, and that's why I have a negative out front of my answer all the way through. So anytime you do the sine or cosine formula, you're going to get a very similar procedure and a very similar answer. And then luckily, in this case, the tangent is actually slightly easier. So the last problem of the day, we're trying to find the tangent of 75, and that's equal to the tangent of 150 over 2. And again, just to clarify here, so this 75, the 75 is the u over 2, where the 150 is the actual u. So just make sure that you know the difference. When I go back to my formula sheet, if I'm trying to find the tangent of u over 2, notice that the formulas are much simpler, which is nice. You could choose either one, but just FYI, it generally is easier to choose the first one. And the reason why is because of the denominator. Because of the fact that the denominator is a single value as opposed to the other version where it's a binomial, this usually winds up being the winner when you're trying to solve problems. It should work either way, but it will generally be easier if you choose the first one. So notice that there is no plus or minus to worry about here, and the formula is simpler, which means that it will be an easier procedure. So according to the formula, and again, I'll just write that over here, it's 1 minus the cosine of u over the sine of u. So in this particular case, it's 1 minus the cosine of 150 divided by the sine of 150. You would, of course, want to know all the important information about 150. So if I pull up my unit circle and I locate 150, this is the ordered pair in question. And of course, this is the cosine and this is the sine. So those are the values that I'm going to use. So as I go to fill this in, this is going to become 1 minus The cosine of 150 is negative radical 3 over 2, and the sine of 150 is positive 1/2. Up in the top, minus a minus becomes a plus. I'm going to go ahead and find a common denominator there. So in the top, over 2, that is going to give me 1 plus radical 3. Oh, sorry, 2 plus radical 3. Oh, this should just be a 1. Sorry. Okay. So finding that common denominator, 2 plus radical 3 over 2, and this is all divided by a half. Final step is to go ahead and do the keep change flip. So if I do that, I get 2 plus radical 3 over 2 times 2 over 1. Lucky for me, those 2's are going to cancel, and I'm going to wind up with just an answer of 2 plus radical 3. Again, whenever you're asked to find an exact value, whatever formulas I tell you to use it for, you're going to get these weird looking answers with lots of radicals, lots of 2's and lots of 3's, and that's just because of the limited values on the unit circle, so don't be surprised if that happens. So here is tonight's homework, number 64. Again, notice that it's in 2 sections. So in section 5.4, 23 to 35 odd, 71 and 72. And then for section 5.5, 9 to 12, and then 42, which again, be sure to do all 3 parts. That just means the sine, the cosine, and the tangent. So we're nearing the end of chapter 5 here, so I hope things are getting easier. Thanks very much for tuning in, guys, and we will catch you next time.